This should be the first of hopefully many videos for a new series of programming videos where I go over, or I not really go over, but I go through the process of developing a WebAssembly runtime / interpreter from scratch in Zig to suit my needs. So if you've seen another video on this channel, I go over a game engine sort of demo idea that I've worked on where I use WebAssembly to drive the engine itself. That way I can essentially write the game code in any language I want, and I don't have to, worry too much. I can just kind of write it in whatever language I want that compiles to WebAssembly, and then I can load that directly into the engine, and then the game engine itself will run that and take care of all the platform-specific stuff. And so I want to use Zig to actually write the engine because I want to own the tools I work with when it comes to this engine, because I'm kind of buying into this whole ecosystem of using WASM to do everything. Then I want to have full control over that runtime rather than using a separate tool to do that for me. So this is kind of the first first video where I'm going to start writing the full interpreter from scratch. And then, if things go well, then I'll write the game engine around that, also in Zig, put the interpreter in that, and then call it a day. Then I can continue on as normal. So yeah, this is the project, just a main.zig file, nothing in it. Our build.zig is just a super simple static library build.zig. Then we also have a test WASM file, and then this build file simply builds it with Zig, calls WASM-LD, WASM to watt, so that way we get the watt file out of it afterwards, and then also the WASM file that we're going to be loading in and interpreting, and yeah, it should all just work. So that's going to be our test file. So I have nothing in this file, so we got to go from scratch, and so I have the WebAssembly 2.0 draft documentation that has all the information about the binary file, the binary file format. So yeah, we're just going to read this and go from there. So I've already read some of this to get ahead of it, just so I'm not starting fully from scratch. So I know a little bit about what's going to go into this WebAssembly file, but I've never written a WebAssembly interpreter or have even parsed this file format before, so it's going to be some fun stuff to figure out. So the main structure around WebAssembly is a module, and so modules are the start of a binary format. So if we go to this watt file, which is just WASM converted into the text format, see that it starts out with a module. And as far as I know, WebAssembly right now doesn't support multiple modules, but that's a thing in the future. Granted, if we're writing our own interpreter, we can kind of do whatever we want. So we can support multiple modules, or if we want to do dynamic linking between the two and all that stuff, we can just do that. No one's going to stop us. So we have a couple functions. So we have types and then functions, and then our memory that we are going to be using in this WebAssembly sandbox, and then a bunch of global things. I don't even know what these are yet. I think these are just global variables. Yeah, pretty sure these are global variables. And then we also have the exports, which are just what we are giving to the host machine, or what we're telling the host environment that they can call. And then if we imported other functions, so if I go into here and I think I can do extern in Zig. I'm not the best Zig programmer. I do like Zig quite a bit, but I just don't use it that much. I'm still trying to get used to it a little bit. I think we can do this. So I'll do foo, and that returns void, and maybe that's going to yell at me. Do I just need to do this? I could have sworn... yes, that's what I need to do. It needs to be a function, of course. So I can do something like this, and then if I want to call this in add, and then build the WebAssembly, I should see, yep, import env foo, right? And that will have a type in this type table that is referenced to that. And so the host environment needs to provide us with this namespace env and then a function called foo that meets this type signature. So in this case, right, it has no arguments. But if, say, I gave it a string, so I think I can do this in Zig. It might yell at me because the calling convention. Yeah, so it is going to. So in Zig, you need to do what you'd normally do in WebAssembly, which is the offset of the string. Because say we're going to call it like print or log, I think would be better. And then we also need the length, which is an I32 as well. So now if we have our own string, yeah, we'll do hello world, and then I can log it. So stir dot, there should be a data pointer here. Do I need to do this? Maybe not. Do I need to? There should be. Yeah, there we go. So stir.pointer, stir.len, and now we can actually call into. Oh, I also need to do this. So I wonder if I can actually. Let me see. I wonder if I can do this in WebAssembly. And it doesn't look like I can. Oh, I actually can. Okay, so now I can do this and then pass in a string, and then there we go. So now if I go to here, see type 0, takes param I32. Now this is passing in the wrong type. It's actually passing in a reference because this is supposed to be a pointer. So in reality, it would be an I32 len I32, and then we'd need our own like log that then takes a stir, and it thinks I'm writing, Copilot thinks I'm writing Rust for some reason. We're just going to do my log. If I can type properly, I'm also using a new keyboard, so bear with me. Yeah, stir.putter, and then stir.len, and then I think we need to do int from pointer, I think is what we need to do. And then as I32, I think that's what we have to do. And now I can just go call my log stir. So as you can see, there's already a few annoyances. Expect to type I32. Oh. Do I need to do int cast instead? Oh, right, it wasn't that one. Or was it that one? Yeah, it was. It was actually both. So I wonder if I can just do int cast instead of as here. And this is just me figuring stuff out because I'm going to have to figure this out in a little bit. Yeah, and then we can do the same thing, int cast, like so. And there we go. So now this is a proper string type signature. And then if we call end, that points to here. And then if we go into our add function, you'll see that there should be a call to, where is it, to my log. So this is the implementation of my log. Yeah, call my log. And then we give it the string, right? So we have this offset into memory. And yeah, so that's how that works. We're not going to be doing any crazy stuff like that yet. We are just going to be trying to get the file parsed into a module. So let's do a const module in here, and we're going to need a buffer of bytes to load that into, and that's just going to be a const u8. And then we're also going to need a fixed byte stream because we will want to read from this buffer, and Zig has some nice utilities to do this. So we're going to need std, and then we're going to call a stream io.fixed buffer stream, and that's going to just take in a const u8 as its type. And then of course we always need our nice init, which will return a self. Whoa, my Vim mode is getting a little crazy. So we're going to need that. Const self is this. And we're also going to need an allocator eventually. So we might as well have a mem allocator that our init function takes. We're just going to return nothing for now, or filled out nothing for now. And then we also need a dinit that's going to take our self. because, yeah, that's what we're actually going to... This is like the main stuff we're going to need. We need some way to initialize our module with an allocator, give it some information, and then a way to free up everything afterwards, because we want to be at least a little responsible with our memory. So let's make a new function called load, I guess, binary. And that, we're going to leave the loading of the buffer. Actually, we'll handle that. Actually, no. We're going to not handle that for now. We're just going to tell them to give us a WASM binary, and then so we don't have to deal with any of the platform, like the file system. We want we basically want this WASM interpreter to be as what's the word I'm looking for? Platform independent as possible. And so we want to tell whoever's calling into this, hey, just give us a binary. We'll do everything else from there. But you handle the loading and unloading and all that stuff. It just needs to be kept in memory as long as you want this module around. So we'll do that for now. We can always change this. It's not a big deal. So now in our alloc, or in our init function, we're going to return a self, and this buff is going to be undefined by default. Same thing with the stream, because that's going to be in our load binary function. Alloc is going to be alloc, and that's it. So the first thing we need to do is we need to do self.buff is WASM binary, and self.stream is, not new though. And we'll do that, and we'll make sure it's just self.buff. I like, once, if I have a function like this, once I set it in the struct itself, I like to use that instead of the argument that was passed in. It's really just a stylistic thing. It doesn't really make a difference in this case, or in most cases. But yeah, now it knows we already want the magic number, so let's just do our reader, and that's going to be self.stream.reader. And now we can read the magic number. So the magic number, as it's said in here, is a 4-byte magic number that is 0 ASM, and a version field. Current version is 1. And so we can see that version is also a 4-byte value. So it's a U32. So we can just do const magic, read, I think it's read no EOF. No EOF. Yeah, read bytes. No EOF, and we need 4 bytes, and this is going to be something that can error out, so we need to do that. And now stud.mem equal magic number 0x00 ASM, and we're going to return error dot. Yeah, we'll do unexpected mat. Do I want to do unexpected mat? We'll do invalid magic instead of unexpected. And now we also need the version number, which it already knows what we want to do. If version not equal to 1, error.invalid version. And actually, this will be unknown version, right? Because if they give us like one with the version 3, that's a correct version, but it's not one we know how to work with. So it'll be unknown. So now that we have that, let's quickly just write a test loads binary. This is just to verify that we at least know how this works. Okay. Nice. That just loads everything for us. But it loads it a little incorrectly. I think the version it uses is a bit outdated, but that's okay. So we're gonna do this all ourselves. So var module is module.init alloc. And yes, it did write this code already, but I don't trust it fully. And now, let's do a const binary is embed file. And I think it is called test.wasm. And that is correct. So now we can do module.load binary, binary. And this doesn't return anything, but it can error, so we need to try. So now, we can do a nice Zig build test. And we already have an error. Unable to open test.wasm. Why can it not open that up? Is it... Oh, probably because it's on the source directory. So we need to do like dot dot. Yes, and we can't unless it's inside. So if that's the case, you know, we'll do a nice binary cwd dot open dir. You know, this is already kind of getting annoying. Dot read. What is it? Oh, is it not open dir? The LSP for this is not the greatest. Okay, what is open dir options? Access subpaths, no follow. That's fine. So we're gonna do root is that, and then we will do binary is root dot read file. And actually, why is this yelling at me? Oh, because it just deleted all, or I did? I don't know why. Maybe that's why. I think that's why the LSP was kind of freaking out. Okay, so now we can do const binary is try of that. Now we can load the binary. So that, whoops, that should work. Root.read file. Oh, I think it's like read file alloc. No member read file alloc. So this returns. Do we try that? We didn't try that. Whoops. That's probably why. Yep, there we go. Read file alloc. And then what arguments it takes? It takes an allocator, a test.wasm file, and then std math max int of u64. So we want our oh yeah, we need to make that an address. Incompatible types. Oh, right, because we need it to be a read int, and then this is going to be a u32. Oh, and what is read int complaining about? Endianness, right? So WebAssembly is a little endian machine, or a little endian format, so we can do that. And why is this yelling? Can't, okay, it can't open the file. So maybe we need to do dot dot slash, or I guess we could do open, I guess we could just do cwd. Because now it should be going from the directory that we ran the command in, and it did. So that worked as intended. Now let's add some little debug printing just to make sure. That's exactly what we wanted to do. All right, cool. See, Copilot's okay in some cases, but not every case. But there we go. So now we have our version number and our magic being read, and now we have a module, which is going to be a bunch of sections, one after another. And so a section is a 1-byte section ID. So we're actually going to need another thing, or another type called section ID. And all right, that's cool, I guess. And are these are U8s? Yep, because they're 1 byte. So custom type section, import function table memory global export. And because we're using Zig, and Zig likes to do stuff like this, is there an element one? Yep, 9. We are going to do that, because that's what Zig likes for its thingy. And I actually want to make these not... I want to make these their hex numbers instead, because that's how we're going to be seeing in the binary. So 0x1, 0x2, 0x3, 4, 6, 7, 8, 9, XA, and 0xB. That's correct. 1, 2, 3, 4, 5, 6, 7, 8, 9, AB. Oh, we also need a data count for 0xc. But yeah, okay, so that should work as intended. So now we're going to need a couple little utility functions, and I kind of want to put this in another type, but for now we're going to not care. So what we actually need to do is or an internal function, and some people like doing that. I want to do a nice, well, do a separator for me. There we go. That's a long separator. Okay. That's fine. So this will be how we mark private stuff just visually. And so what we want to do is we want to do a read section ID. And that will take a pointer to self. And we actually should store this reader somewhere. So stdio reader. Because we are going to need that. And it is yelling at me, but it is okay. And now we can do self.reader, self.readInt, and this should really be like read preamble, all this stuff, but that's okay for now. So we need a section ID, and this is going to be, it's going to take in nothing and return a section ID. So we can do self.reader.read enum, and I think this read why is it not let's see, is this not actually the type that we want? So stream reader, it returns a reader. So fixed stream, what does it call reader? So in this case, reader is an IO reader, pointer to self, read error, and read. So we actually want the, can I do this? I think we want this, stdio fixed buffer stream, const_u8.reader. And of course we can make this easier on the eyes later. It really doesn't matter. But for now, it's okay. So now that we actually have the reader we want, enum, and we want a section ID and little endian, and we are just going to return a try of this. So now we can, let's see. So each section is a 1-byte section ID, then the size of the contents, and then the actual contents. So what we really need is like a read section. And this will return void for now because we don't have a section type yet. And this will simply have our type. I don't know if I can use that as an identifier, but we'll find out. Read section ID, and then we'll do a switch on the type, and we'll just do, I guess we'll call it ID. So the first one, so custom is going to be this. Then we have a couple different ones. So the custom section, do we even have that in our WAT file? We don't. We have the type section though. So we're going to do the type section first. So we need to like an else, and that's going to return error unknown section. And we can have type. It's weird that we can use .type as a valid identifier, but we can't use export as one. Maybe that's because that's like a future plan or something in Zig. I don't know. But okay, so we got a type section, which is this. This is their notation for how they describe what this sort of thing produces. So it is a section of this index that includes a vector of function types, and it returns 0 or more function types. So a vector, I think a vector is just, yeah, U32 length followed by the encoding of their element sequence. So we need like a read vector, but that might be too generic, and I don't want to start making generic functions. So what we're going to do instead is return try, and we can actually do this. We can actually do that. And we'll do a try. Actually, we don't even need to try, because it'll return an error. And we do want a read type section. Thank you. So we can do read type section. And we'll make this return void as well, because it really should return a section, which I think we're going to make like a union. Maybe not. Maybe we just have a return an error void, and then read type section populates a type table inside the module. That might be better. Just judging by this, because all of the types that we need, every type that we need for the module is going to be right here. So we don't really want to have like a generic like section type that then we read into. I think that's a little too complicated. So I think we just want this. So because we know type is a vector, we need its, I don't know why I'm talking so weird today. Because it's a vector, we need its length, and then that'll be followed by everything it encodes. So we need len is self.try self.reader.readInt u32 little endian, and we probably, because we already know it's little endian, we probably want to do another thing like read section ID, but called readInt, just so we don't have to specify that everywhere, because it's a bit annoying. So we'll do that. Comp time t any type, it returns a t, actually an error or a t, and then that's just going to be self.read.readInt. Yeah, t little. Yep, it was right. So now we can do const len, and this also lets us control how the erroring happens, right? Rather than in this case where we're just returning whatever error readInt returns, we can have it say, unable to read int, blah, 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 at this section. We can actually sort of take over the error handling, which is nice. So we want just a nice little U32. And we probably should also specify the type. We probably shouldn't need to specify the type and make it like read length. That then is always U32, because U32 is going to be the length everywhere. But we are not going to care about that yet. So what we need to do is the type section is going to be a bunch of func types. And a bunch of func types are 0x60, this byte, followed by a result type, then another result type. And I think this result type is a vector, of types, of val type. And val type can either be a num type, a vec type, or a ref type. So we're going to need a couple new enums in this case. So we want our like these special types, these function types. Actually, I guess we can put these all in a same struct. So we're gonna do type is an enum u8. Let's see if it'll populate all this for us. Maybe not. Let's see if we can get it to do all this work for us. That'd be kind of nice. I32. Yep, that's exactly what I wanted. Any func. What is any func actually a thing? I think it is. I think it is in here. Value types, result type, func type. Maybe not. Oh, it's called func ref. So it'd be func ref. And then empty block type is 0x40. I don't think that's actually a thing. So it got close, but it didn't get all the way there. 0x40. Yeah, it's not a thing. So we have I32, which is 7F, I64, which is 7E, F32, 7D, F64, 7C, funcref is 7D. And then we're going to have, so we have our main types, vec type. So we can do vec is 0x7b. And I'm not going to put I'm going to put these in the order that they are in here. Just so that way I don't have to do something like this where vec splits F32 and F64. I think that's a bit goofy. And then we also need 6F, which is an extern func. Or sorry, extern ref. Yeah, extern. Yeah, func ref, extern ref. 0x6F. Right, so we want these. And then we also want this result type to be its own thing. I think, let's see. Yeah, because I want these like func types. I want these big types to be their own thing, right? Like limits is going to be 0 or 0, 1. Oh, but I guess that should really only happen when we read the type. I kind of want to leave that alone. Yeah, because table type is a ref type followed by limits. Global types. Yeah, so we'll leave it right now. We actually do want that, but we don't need that yet. So it is the length. Let me just make sure, because it's a section, so it's a vector. And so we'll do like size of the section, so section size. And now we need to read 0x60. So self.read byte, reader.read byte. And we need tag. Yeah, I'll just call that tag for now. And we need to say if tag is not equal to 0x60. And this would be, you know, where that read enum comes in handy, because we could actually, yeah, we'll do that. I like that, now that I called them tags. And let's see, is it going to know what I want? It does know what I want. Okay, cool. Yeah, let's just make sure that it did the correct thing. Result type, func type 0x60. A param, I don't know. Is this really just for... This might just be for func at this point, because result type is going to be its own thing. Yeah, so we actually don't want that. So we want like function, we want limits. Limits is... So we'll do like limit is 0x0, and then limit max is 0x01. And we're going to add some nice underscores here. So yeah, func, limit, limit max. Yeah, so now we can actually use our read enum function. So this will be self.read. Oh, well, it's called section ID. So we're going to need like a self.read tag right here. Read tag. And if we had like our own read enum function, which we could still do, that would also be convenient. So we wouldn't have to specify a separate function. And we're actually going to do that, because that will save us some annoying typing later. And it's actually going to save us some annoying typing now. So now we can do a read enum, and that will have the type specified still. So we can swap this over to read int actually. And we can keep that at read bytes, no EOF. Unless we need to do that later, which I will do later. Read type. Oh yeah, okay, so read enum section ID. And we need to try this. So now we have our section size. And we have our tag. Tag. So we can go if tag is not equal to func. Then we return error.invalid tag. We could call this like expected function, but we're just going to call it invalid tag. And then later, we'll actually attach some data to this. We'll attach some data to this in the sense that, what's what I'm looking for? We can specify what tag we got instead. So we need a result type, which is a vector of val type. And then, let's see. Yeah, so RT1 is a result type, and RT2 is a result type, and those are vectors of val type. So we might actually need a read vector, because we're basically going to be doing this a bunch. But let's go back to modules really quick. And yeah, these are all U32, so we have the type index. I thought it was going to bring me to the type section. It did not. Yeah, so it's a 1 byte section, U32 size in bytes of the contents, and then the actual contents. So we need to go to a type section. Yep, so that's going to be a section, so that 1 byte section ID, which we've already read here. Then contents in bytes, and we're just going to do this because we're not going to need that yet. And then the actual contents, which will be vector of func type. And then that is a vector, 2 vectors of result type. And we're still parsing a vector. So in this case, we need to do something like while I less than section size or something like that. Yeah, we need to do something like this, where we go while. We actually could just do a while true. And then if we can do if self.reader.position, I think is what it is. Yes, one section size break. And we could just do that in here, why not? And there we go. So now we actually need to read the tag. And I kind of want to put a, I kind of want to make a separate function for reading vectors, but I think they might be too specialized in this case. So we're just going to do it inline for now. So now we need a vector result type. So that is a vector, and vectors are, of course, their length and then the contents. Right, wherever the fuck they put it. Probably shouldn't be cursing, but you know, wherever that is, I'm pretty sure it's just that. And I think if we're lucky, we can click it, and it'll bring us to the wrong. Oh no, it didn't. Yeah, U32 followed by the encoding. So it is just a U32. So we can say arg len. Let's try self.readInt U32. Thank you. And then we need another while self.stream.position less than arg length. Whoa, I did not want to do that, but I mean, I basically do want to do that. So I think what we can actually do is after we read the length, yeah, I could do like a whatever it's called, reinterpret cast, or like a transmute, where we have like our type table. No, actually, for now we're not going to do that. That's a bit too involved. So, func table. What is it called? Modules. Type section. Func type. Func type is that. And then we can do this. Yeah, I don't think this isn't actually correct. Stream position less than arg length. Because stream position is going to be some arbitrary, so we need to do like const pause self.stream.pause, and then we need to use yeah, while pause. Wait, no. What am I doing? Because we just want to read that whole section. I wonder if I can do something actually kind of goofy. self.stream.reader. I wonder if I can just get that whole section. That'd be kind of nice if I could just get like this slice of the section and then create a reader from that. So that way we don't ever read over. Like we don't have to actually manually manage the position of one reader. So I wonder if I can do like var rd self.reader. Yeah, we could actually do self.fixed st.io.fixed buffer stream. We could actually kind of do what we did earlier. I don't like this. I just want to see how this works. Self.buff, and then yeah, that's what we want. We want up to section size. And now we can do our reader dot, I think there's like, I thought there was like an empty. Oh, because we actually need a stream separate, and then we need our reader. Right, we actually need like this, and then we can do something like this. While stream dot. What was it? Yeah, actually, we could do stream.pause less than section size. But then, we're going to be doing the same thing here, so it's kind of like... wait, no, we're not. Sorry, I'm going crazy. We just need to say pause is st.pause, and then while pause is plus arg length is greater than the... No, that's not correct. Because we get we get the number of arguments that we need. I guess we could also just do a for loop .arglen. Yeah, that's all we actually need to do. I don't know why I'm overcomplicating this. And is this not how we do in... We don't need the I. So we're just going to debug print type for now. T, and then... Oh, but now we also can't use our read int. Yeah, so there's some annoyances in that. So we don't actually want to do that. So self.reader.position. I think that feels incorrect to me. While the position is less than the size, like that's gonna break. Because it will never be less than the size if the size is like nothing. Whoops. That's not what I wanted to do. That feels more correct. But it's also not correct. I guess we can just chuck in a while true in here, and then we'll just do... boom. And then after we read the retlen, we need to keep going. Yeah, so we actually do need the section size. And now section size, I think the confusing part is section size the size in length, or sorry, the size in bytes, I think is what it said. Section contents in bytes. So, yeah, so we read the tag, and then we get the arg length, we read all the arguments, and then we get the return values, and we return all the we read all the return values. If I run this right now, this will run. I don't know why it returns. Did I screw something up in the above function? We only do have a type section. Are we not calling? Oh yeah, sorry, we're not calling that. So we actually do need like a while true right here. And then we can do something like this where we do like a read section. And we just try. For now. Whoops, that's not what I wanted to do. There we go. So now, e.invalidValue. And we didn't print out anything, which is a bit annoying. So this was what? Const tag. To the read section. We switched. Did we ever get to read type section? No. We did read. Section. And I am going to call this section instead of section ID. Actually, no, we'll keep it because if we have a section defined, then that'll be annoying. So type should be 0x01. Yeah, 0x01. 0x02, 3, all the way to 9, then ABC. Let's see, we might have to bring out the debugger. I think we will. So let's go to here. And can I do that? Run into bug. I think it's LLDB. No. Workspace. I think that should be Zig out. Oh, actually no, because we want it to be Zig test instead of that, so we can debug our tests. There has to be a way to do that. Oh, Zig language extras. Yep, that's what I want. Sign me up. Okay, and now we should be able to debug with LLDB. I do not like GDB, but I might have to use it, unfortunately. Okay, is there like a debug test? Don't really want to type in that, but oh. Okay, I guess that'll just work. Neat. Okay, so let's see, local variables. So we need to just skip over this guy and go to the return switch. Actually, no, we need to step into this guy because it fails here. Okay, so tag is that 0x01. Okay, it seems like, yeah, okay. ID is type. That's correct. Let's put a breakpoint there. Goes into our read type section. Section size is a very big number. That is incorrect. So is it reading it wrong? Or is wait, let's see, U32. I think I have to do what? No, it's a U32. I wish there was a way to see the buffer at its current length properly. Yeah, because we're just at position 13. Position 13. Yeah, I'd have to set up something in the watch window, and I don't really want to do that. Yeah, why are we back here? That's a bit strange. Yeah, that's a bit goofy. So let's go back into that, actually. So we go here. We're trying to read a U32, a little endian, U32. Then we're at position 13. So I'm just going to go into the WASM file. Go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And I think it's probably actually trying to read this. Is that going to do it as how I want it to? Maybe I missed a step. Maybe we're actually not supposed to read that yet. And so I'm reading on like the boundary of two things, probably. So yeah, read our magic number. Then we read an int. The U32 for our version, and we can check that. So we read the magic number, which is 4. So that's 0 ASM, and then we read 4, which is 1. And then after we do that, we read, let's see. Then we read magic version, a custom section. Oh, it's probably because the custom section, I think that we have to read the custom section even if it isn't there. We can't just skip to the type section. Yeah, I think that's what we have to do. Because the custom section is here, right? And so it has like a 1 byte section ID and then a U32, right? So it'd be like a 1 byte section ID. Which, I mean, this looks like the type section. This doesn't look like the custom section. So maybe we can skip that. Because the thing that should come after this should be the custom section by what it was saying, right? So version, custom section, that star means 0 or 1 in the conventions. Or sorry, 0 or more, right? Possibly empty, where n is not relevant. So yeah, we read the 1, which is a 1 byte section ID, and then 4 bytes for the total size, and the total size is a U32. So this would be U16, U32, 1, 2, 3. Actually, no, what am I saying? I'm dumb. Yeah, this would be 16. I don't know why I was getting that confused. U32, I don't know why it's some crazy number. Is it just reading? Do I not even have to highlight it, actually? Is it just reading a U32 from here? I think it's actually what it's doing. Because if I select the big thing, it doesn't actually do anything. So I feel like I'm missing something, because it should be... So we read the magic, which is 4 bytes. Then we read the version, which is a U32. I'm pretty sure, right? Because this would be 4. Unless it is 1. And this is the custom section. The 4-byte magic number in a version field. I'm pretty sure it says version somewhere has is a U32. I remember seeing that. Let's see, version. Because that could totally be the issue, is that we're reading a U32 and we should just be reading a byte. Let's actually try that and see what happens, because I feel like that could be it. I don't know if they'd ever do a U32 for their version number. That seems a bit strange. That's not what I want. I don't even know what that is. Oh yeah, we want to just run the test. The debugger on the test. Okay, yeah, it tried to run it with the command I just accidentally typed in. Did that crash immediately? Yeah, unknown section. What? What? So, okay, so it is a U32. So why was I saying... Yeah, why does it just not say that it's a U32? And also, why would they use a U32 for their version number? That seems a bit weird. But also, this passed. Wait a second. Yeah, okay. I'm not too crazy. Yeah, we are getting here. So we go here, we read it. Yeah, okay, I think what's happening is exactly what I was saying. So we have the 4-byte magic, then the version number, then the custom section ID, the custom section length, which seems a bit weird. It should be 0 because there is no custom section length. And then the type, which, why is this 60? Like, what is going on? Okay, so 1-byte section ID, the size of the contents in bytes. So if we read a section, it is the section ID. So it'd be a U8 1-byte section ID. And then we have the section size in bytes. So the contents in bytes, and that's a U32. And the actual contents whose structure is dependent on the section ID. Okay. I bet it's just this while true is fucking things up. So we can just do like var I u size 0, and that would be that's the section size, and then we're just going to do I plus equals 1 for now. In reality, what we should do is, while I is less than the number of bytes we've read, increment by the number of bytes we read. That's actually what we should be doing. But the weirdest part is I would expect that this would print anything. Right, we're not getting any printing, which is what I'm expecting, so... Yeah, and I also don't know why this is... I guess I get unknown section ID, if that is the error we're getting. Because we don't have a custom section yet. So if I did like custom... And you know what, I'll actually do this just to stdebug print. And we'll need to do like a E break E. And we're going to do something like this, and this will be ID. And I'll just do invalid section. Because if this happens, then we should see invalid section 0. But we don't, because for some reason it's not printing the failure. Probably because it's failing before. No, sorry. It's not printing out what we actually want it to, because the test is taking over standard out and probably not printing what we want. So we're just going to do this bad boy and debug the test. And we do get an unknown section, but we don't we don't hit the else breakpoint. Okay, there we go. So ID is custom. And then we fail. Okay. So we actually need like a dot custom is self dot read custom section. I guess the custom section is there. It's just not filled with anything. I mean, it could be filled with anything. That the WAT file just doesn't show us. That is super true. But I also feel like it should. It might be this. It might be this data segment right here. Yeah, that might be the custom section. But wouldn't it say custom here? Wouldn't it be like custom blah 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 blah. You know what? Let's do this really quick. Create a hello world WASM file written in Watt. Let's see if it'll actually do it for us. Let's see. Include a custom. Include the custom section. Okay, well, I don't know if that's correct, but that's what I would expect it to look like if there was the custom section in there. So let's just do this, and we'll do this. And const section size is try that. And read int, please. And then if section size equals 0, return. Because we won't have anything. So now we can do something like this. Debug. Okay, now we're going to go there. Read that. Read the section size. That's going to read int. Whoops, that's not what I wanted to do, but that's fine. We get the section size 0, but it's not. Whoa, it's not 0. It's some crazy number. Yeah, so something about how it's reading our numbers is kind of not great. Oh, that's not what I wanted to do. Yeah. Why is that? I guess we can go to values. All integers are encoded using L. Oh, right. Duh. So we actually need LEB to decode these, even though, yeah, U of N. Yeah, so that's probably why, because they're LEB encoded. And so it's probably fricking up everything. So return self dot read, what is it? LEB dot read ULEB. And I think we need to do a comp time if. So if type info of t equals integer, I think is what it is. Is that correct? I don't know if that's correct. So if it's unsigned, then we want to do an leb.readu of t self.reader. Otherwise, we're going to do a read I. And see zig build test. And that did, yeah, there's no unsigned integer built-in type. I think it's just integer. And we need to go to the Zig manual. I think it'd be the language reference, and we can do type info. Returns a standard built-in type. That's helpful. So we need to go standard built-in type. So it's just int, and then int has signedness. Okay, well, it's not what I really want to do. Int. And then, wait, can we actually do a capture here? Can we do that? Is it going to be a frickin', yeah. It's not equal dot signed, unsigned. I don't actually think we can do that. Yeah, because that's an optional type, so we can't capture it. So I guess we could do const info. Actually, you know what? Let's just simplify this. Read uint t any type because we're going to specify any type. We're going to do that, and then we're going to do a read. Actually, do we even need signed int right now? I think we actually will. Read sint. I like sint for signed integer, personally. And I don't know why I'm not just doing that. Sint and read ileb. So now we need to go update everywhere we call read int, because now these are going to be read uint, read uint, read uint, and read uint. Okay, so now if we do a nice little debug, I'm going to read that custom section. It's going to read the uint. It's going to go, hey, section size is 0. Awesome. We don't need to read anything. Then we go there. Done. Read section again. Boom. I don't know why I keep doing that. What is the section? Custom again. Okay. Is it because of the version number? Is the version number really? There's like no way. This is a bit annoying. Yeah, I don't know why I'm like kind of blanking out on how this works. Modules, and see, this is why I kind of want to record this, because it is sometimes a slog to do anything, just based on not understanding the problem or using a new programming language. Yeah, it's a learning experience, and that's what makes it fun. So hopefully you're getting something out of this so far. I am, but you know. We'll see. Okay. So, we have our version number, right, which is a U32. We've specified that it's a U32. And we actually need to differentiate this, because this is just 4 bytes. So we need to do this. Like, we're going to do like a self.reader.read int U32 little, because we know it's 4 bytes. Okay, so we get our magic and our version. Then we get our custom section, which will be section 0. Now it does say custom sections, so that's kind of annoying. So custom section is a section of custom, which has a name in bytes, which we like totally don't have in this WAT file. There's no custom section. So I think I can actually ignore it, because there is no custom section. And so I will proceed to do that. Because I'm just not sure what is going on. Okay, so now we get the type section back for some reason. So we can jump into there. We get a nice section size of 22 bytes. Interesting enough. And so what is our position? Oh, I'm so stupid. I could just do max section is pause is self reader.pause plus section size. And then we just need to do while, I don't know why I wasn't thinking about this earlier. Oh, is that going to be stream? Pause less than max pause. And this will be stream.pause. And we don't need an I anymore. And that should still work. Because we get the number of arguments, right? Because a vector is the U32 length, right? U32 length of the vector, followed by the encoding. So we know we have 0 to arglen, and actually, I'll do another little, so we actually use this. So I'll do a nice little I right here, just so we actually use it, because why not? And this will still fail, of course. Oh, is it not a function? Cool. I like that. And usize needs a different format string. What? Why can't I close my terminal? Okay. Oh, because I did it in the wrong spot. Whoops. That'll do it. So this will still fail because now we're going to get to a section that we don't handle. But if I do this and I say const x equals 10 underscore equals x, and I stop it there, and I do one here and here, we should actually hit these breakpoints after we hit the other breakpoints, of course, and we don't. So why is that? Why do we not hit the breakpoints? So max pause is 32, and section size is 22. So we should at least do one iteration of this loop. So we read an enum tag. Tag is not what we're expecting, and that is the problem. Okay, so we, I guess I'll just use read byte for now. I guess I'm trying to be a little too fancy, and that's biting me in the ass. So our function tag is 0x60. Thank you. 0x60, right? Because we have in our modules, it's just going to be a bunch of func types. Func types are the value 0x60 followed by a bunch of shit. So we go through here, read 1 byte, it's 0x4. Okay. That is correct. Sorry, it's incorrect. Why is it 0x4? We already got our type section. We got our... I think I'm just misinterpreting the syntax. This is actually why I hate this like EBNF style syntax for this. I would much prefer just a direct binary, like this, then this, then this, and not having this like EBNF where we have this like output terminal value, or we have like terminals and non-terminals, and then we have like combinatorial types and all this shit. Like, it makes sense because they have these sort of like higher level abstractions of things, but I'd prefer it if it didn't have that. Maybe that's just me. So a func type is a result type and a result type. So it's a vector of func types, right? And so we go to this module, we go back here. Maybe if I did have a read vector, it would be a little easier, but I just don't really want that. Type section. Type section is a func type, any number of func types, and that is going to be a section, and a section has a 1 byte section ID. Right, so we are reading this correctly. This is probably so infuriating to watch, actually, now that I'm thinking about it. I don't usually program and record just because I feel like I am a worse programmer when I'm recording or like screen sharing for people. So I think that's probably a part of this. But so we read our section ID, 1 byte, section ID. Then the U32 size of the contents, which we read here. So read uint32. And the actual contents, which is the tag. In this case, we have our type section. So it's a vector, so we get that size. Oh, are we not reading the vector size? Is that why? Oh. Wait a second. It said 4. 1, 2, 3, 4. Yep. Okay, wow. That's stupid. That's very dumb. So we actually need number of types is try self.read uint u32. And now we don't need any of this stuff because now we're just going to read 4 types. So we're going to do 4 0 ... number of types. And I guess we can call this total types instead of number of types. It's a bit long. Can I do there? Yep, total types. And we don't need this capture. And now we just need to read that. So we actually don't even need the section size. We could have... we'll have some checks because we'll need to validate this. Because you're supposed to validate WebAssembly modules as you sort of parse the module. So we actually should do that. But yeah, so now, okay, well, that's stupid. A little bit of a dumb mistake on my part. If I had that read vector function, probably would have caught that, but that's okay. So we have 4 types. Now we're going to read the byte. Is it 0x60? Yep, it was. So now we can actually go back here, change this to read enum, and we'll call this tag is not equal to func, invalid tag. And now we don't need any of this shit. And it should actually print now if we run zig build test. It doesn't print because it probably hits an invalid. Yeah, actually, it does. Perfect. And you know what we'll do? We'll even do one right here just to mark it. And we'll call this func. And then we'll do a new line, and then this will be tabbed over, and then this will be tabbed over, so it's at least a little prettier to look at. If you want to make it, you gotta do the thing. You gotta read your total types. So you have to do. So we can verify this. So function 0 has an i32, i32. Function 1 has nothing. Function 2 has i32, i32, returns i32. And then we have another one somewhere. 1, 2, 3. Oh, sorry, I'm looking at it. It takes 4 i32s. So that is correct. Cool. So we've read our function types, and now we actually need to do something with the data. So I'm thinking we have a type table, and that type table is just going to be a mapping of these two things. So it's just going to be like an array of types. Yeah, I think that's probably a smart idea. Like an array of func types. Because I think the WebAssembly spec is kind of making this generic because these might not be all function types in the future. That's why it's specified like here's a type and then it is a function type. And then eventually it'll be like here's a type and here's a structured type or like whatever it's going to do. Because WebAssembly doesn't support structures yet, but I think they're talking about doing it. Or you can do different types of function types. So I think what we want is our type table for now is just going to do function types, but I think I can just do like a union, with one thing in it for now, and it's just an array of unions, and one of those unions will be a func type, and the func type will have parameters and results. And I think that's okay. So we can do like a const, and this is actually going to be like a type tag. Actually, we'll call this a value type because that's what it's actually called in WASM. Right? Result type is a val type. and we'll actually make it the correct thing. Because why not? And so we're actually going to have our, and I'll probably end up doing this kind of thing. So it's specified like, hey, this is a WebAssembly specific thing, and then here is a specific thing to like the interpreter. But for now, I'm just going to do type is a union enum, which is a really awesome Zig thing, which is just a shorthand for making a tagged union, and I can't type properly. But we're going to do a const func is a struct that's going to have params, and that is going to be an array of val type, and then what are they called? It's like params and returns or something. It's really like result type, but I don't like that terminology because it's not. It's like, why would your parameters be called result types? Because they're really not. So we're going to call it params and returns like that. And now we can do a func is a func. Right? And that's all we have to do. And now in our module, we're going to have our type table, which will know at instantiation time what the maximum number is. So we don't actually need to resize it more than once. And I guess we don't actually need to do it because we can just have it be a slice into... No, we still need to because we need to hold our internal representation. So we can do like types, and that is going to be an array list for now of type. Right? But we just need to resize it one time, which is okay. So we're going to do types equals array list like that. That's exactly what I wanted. And we're not going to give a shit about deinitializing right now. Just because. And we'll do a catch right here, just so it's a little obvious. Error, return error. I don't really like that for now. We're not doing enough to need to change this. But okay, so now we got our type section. So we got our section size in bytes, which we will use to validate this. And we have our total types, which we're going to use to do this. So self.types.resize total types. And that could fail. And we're just we're not going to care about what kind of error it returns. We'll probably eventually want this to be like a WASM error, where we say that this was unable to allocate. We could also have this do like a multi-parse approach where we read all of our sections and size everything, so we only have to allocate one time to actually run the module besides like the internal memory. But that's like way down the line. I don't need to care about that yet. But for every function, we're going to do self.types.append. And before we do that, we're going to do const param pause is self.stream.pause. And you'll see why in a little bit, because we're just going to take a slice and interpret that as what we want. Rather than doing an append, because these are slices in here. We'll make these const actually, because we want them to not be modified afterwards, and I think that's how that works. There should be an array of const val types. Actually, that's not correct. I think this needs to be that. But after we do that, now we can do what is it? Const params. Let's see if this will do it. Kind of. It's getting there. That's what we want to do. We want to slice it, but we also need to do this where we go val type, and then we do we need to cast that? I'm pretty sure we actually do, but we will see. And then we can do ret pause, const returns. Oh, it almost got it, or I think it had it. Val type is that. And now we can do a nice, this is exactly what we want. kind of, I think. Self.append dot func dot params equals params dot returns equals returns, and I know it's going to complain. Whoops. Yeah, it's not a function. I keep calling it as a function when it's not. Oh, and I probably need to run the test to actually build that. Yeah, so now we need to do an array cast, which I forget how to do. I don't think there's like an array cast or like a slice cast, putter cast. And we'll probably need to take the address of that. Let's see. Legal. Maybe there is something instead. Mem slice 2. Let's see. Cast slice. Slice cast. Let's see. Is it in the slices section? Okay. Int from pointer. Don't want that. Because we already have it all read. We just need to convert the two slices together. Wait. We just need to convert the slice of bytes to the slice of value types, which is also an array of U8s. It just has a different type. It's basically a type alias. Cast. Can we use a bit cast maybe? Yeah, maybe we can use a bit cast. That might be kind of nice. That might work as intended. Use pointer cast to cast from pointer to const pointer to const U8. Oh, because this is a pointer. Use pointer cast and okay. And let's ignore this for now. We're going to make this undefined so it doesn't complain, just so we can fix this. Cast discards const qualifier. So if we make this const, and then we go and make this const, is that going to do it? Okay, that did do it. Okay, so that does do it, actually, which is cool. So we just need to make stuff const. And I could do that here. Yeah, we'll do that here. Pointer cast, self.buff. Oh, no, because we need like the end position, and that's just going to be uglier. And I kind of want to do it like this, just to show that we are casting rather than relying on Zig's like magic type deduction, where it's using like the variable's expected type to do it. I don't really want to do that, but there we go. So now we have that, and we can just do this because we don't actually need to know the return type. We just need to read it from the stream. Sorry, yeah, we don't actually need to do anything with this. We just need to read it. And we could calculate this on the fly as well. Where else are we printing? Oh, yeah. We could calculate it on the fly because we'll know the total types, and we kind of know the number of types and what their sizes are, right? Val type is just a bunch of bytes. So we could do this where we just slice it directly, and we just need to read. We just need to move the position. So we could do like self.seek, I think, reader.seek.skip. Yeah, we can do skip bytes, which would be arg. Whoa, okay. Self.reader, self.reader.skip bytes. The number of bytes is our arg length. times size of val type. We're just going to try that, and then we just need to give it some options. Skip bytes options. Buff size. Buff size. How does it use buff size? I guess we could do buff size is the size of the section, but we also shouldn't do that because we need to validate the section later. So we could do this, and then we'll get the position by the params, and then we don't need to do this anymore. We just need to read that, skip the bytes by retlen, and then returns are like that. So I like it like this a little more. It's a little more, you know, a little nicer looking. And that works still, or at least it doesn't fail. So we can do debug.print. And actually, why am I just going to do that? I'm just going to do underscore is 10 and debug the test. And now we can go to self types. We have 8. Oh, because we resized it. And it's using probably like 1.5 or whatever as the resizing amount. But we have pointer, which points us to our first one. Crazy length, which means that that's not correct. Can I do self.types? Is that going to be a thing? Yep, self.types dot items 0. Why can't I do 0? Is that not a thing I can do? Oh, is this going to be like C-style syntax? No. Oh, do I need to do dot pointer of 0? Yes, I do. So that'll do it. And then I can do like pointer of 1, which will of course will also be a function type. I think I want to do pointer of 3, which will have a bunch of them. No? 4? So, let me see. We're just going to do a debug print, and we'll do, like, functions. And we'll make this print any, and self.types.items. Because I want to see what this looks like more than I want to see it in the debugger. I guess we can also just loop through them. So for self.types.items. Yep, that's what I want. You got it. Besides the fact that you can't use type as an identifier. But, oh, whoops, I disabled my key. Yeah, okay. So now that is doing the wrong thing. So this pointer cast is doing the wrong thing. Can I do, is there a stud.slice? No. Mem.slice. Let's see. Bytes as slice? That could be correct. Bytes as slice. So we have this const val type and this. Yeah, what is this actually doing? As cast target, pointer cast, div exact, size of t. I could do that, and then this would be params instead. Right, so now the alignment is out because it's aligning of 1, which is not what we want. I know we can do an align cast in Zig, right? Which will at least make that not fail as far as I know. To do implement pointer cat. Oh, okay. Well, we not 1.0. We hit it to do with pointer cast. So we need really. We need. Is it slice 2? Yeah. What is slice 2? So it takes a pointer, any type. Takes an array, a pointer to an array, or a sentinel terminated pointer. And then we need end. So we need the buff. If end is not found. I don't think that's what we want. And actually, we're gonna see what another project does, because I'm deliberately not using this project. But it does do some stuff like this as well, from what I was looking at like a while back ago. I'm pretty sure it's still. I hope it does. Don't they have like a read section thing somewhere? Probably module. Yeah, and see what they're doing. They're doing like section. They have their own section type, which we'll probably end up doing eventually, just to simplify a lot of this stuff. But let's see if they have a, decode type section is what we're looking for. And param self.module. Oh, okay. Oh, interesting. So they just slice it, then they pointer cast the pointer. Interesting. Okay, we can do that. That's not too bad. And I'm going to close out of this. I don't want to use this as a reference. It's more of a Zig related reference. So we can do this. And we can do const, or I guess it would be a var param types is a const val type param. I guess we'll do like I like to call stuff like this raw, just because it kind of makes more sense to me. So pointer is that, and that's what we want. We want a pointer cast raw params. Do we need to do dot pointer? Probably. And then params.len is arglen. And then we need to do the same thing with returns. So raw returns. And we don't, we still need rep pause here, of course, rep pause. And we still get that segmentation fault for some reason. Am I doing this? Is it not supposed to be pointer? Yeah, I'm still getting that segmentation fault. Am I doing this wrong? Skip bytes. Read num bytes from stream and discards them. I guess we can still do what we did last time, is 0.arglen, and see if that is the reason. Try read enum val type. And then we can do the same thing here. Nope, still seg faulting. But why? Why are we seg faulting? So we read the tag, then we do the param pause, which is the current stream position, which will be right after this. Then I read the arg length, so U32 arg length, and then we skip the bytes. And now, of course, we can just read arglen. We can just read a number of bytes, but it's just good to do it like this to show that, hey, we do want to read this size forward. Like we do want to specify why we're skipping forward. So this kind of does that. And then we slice the params from the position to the current stream pause. I don't think we need to do -1 here. We might need to do -1 here, so I'll do that just in case. But yeah, I was going to say pretty sure we don't, because this is going to be inclusive, and pause will be the current position in the buffer, which we know is valid at this point. And so we skip bytes, then we read all the params, which is our const val type. Do we need to do some shit like this? Is that what's going on? No. You know, we're going to go back to zware. And, oh my gosh, if I can type it properly, zware. Let's go back to it and see what they're doing, because maybe I just misread it. What is it? Decode type section. Right, so we read the total types, or the count, which this is actually a better way to do it, but that's fine. They don't really need to do that. Yeah, they're doing it this way, where they just loop through and read it. And what is self.pause doing, actually? Self.buff.reader.context.pause. Oh, because we're reading from the stream. I thought the stream was updated after that, actually. But it's not. I would have assumed that when you're reading from a but I guess we're reading from a reader, not the stream. I don't know why I would have assumed it would update that. So we should probably have our own pause function that returns a usize. And that'll take a pointer to self. I guess it can be a const pointer. And return self.buff. See, but that's weird. So if we do stream.buffer, or stream, like what they did is stream. Reader.context.pause is, yeah, that's what they're doing. And that's what we want to do instead. So what place do we get pause? So we do self.pause. Self.pause right there. Pause. And so we actually did want to do this after all. And we're still segfaulting. Probably because I'm doing this now, which I don't need to do. And let's just double check. Decode type section. Because this is more Zig specific stuff that I'm not sure of. I'm not really using this to figure out how to write the interpreter. I just don't know certain things with Zig. So we actually do want that. We're still segfaulting. So what's going on here? So, oh, that's funnily enough, we have the same read enum thing. So we get our pause, right, which is the start in the buffer. So we have param length, or arg length is what I'm calling it. And like, once again, I'm skipping that. And then we skip the bytes. We get our raw param. So let's debug this. Let's see what's going on here. So param pause is, and actually, yeah, I don't know why I'm calling this arg length and param len. Param len. It's a bit confusing. This is all fine. So we have our raw params, which is a pointer to all this stuff. So it's a bunch of zeros for some reason. Probably because we haven't actually done that yet. Okay, don't know why that. So we have a length of 3. Okay. Whoops, where am I? So params is that val type. So params here points to the address 2, which is not correct. Okay, interesting. I wonder if we want to do something like this, where we actually, since we're reading the context from there, but yeah, I don't know. Now, just to make sure, we have set our buffer to the right thing, right? Yeah, this WASM binary. Self.pause is our ret pause. So we're at ret pause 15. So if I go to self buff, or what is it? Reader context pause 15. We skip over that. Oh. Okay, yeah. Let me re-debug this because I think so type 0 should have 2. Oh. Dot buff. Right, so we're parsing type 1. Type 1 has a param length of 2. That's correct. And it has a return of 0. So we get our retlen, which is 0, and our reader context position should have stayed at, yeah, okay, it should have stayed at 15. After this call, but it went from 15 to 16 after this call, so we're actually skipping 1 byte. So we will do this dot paramlen. We will do something like that, and then we'll do the try self.read enum val type for that. Yeah, I didn't expect that to happen, but it did. So it's probably user error, but you know, do it anyway. So let's have our reader context open. So we get that. Read that. Retlen of 0. We shouldn't have done anything. And we didn't, which is good. Even though it jumped in there, which is probably just debug symbol issues. Raw returns. Pointer cast. Retlen. And then we do that, and now we go to type 1, which is no arguments, no returns. So param length should be 0. We don't actually do anything. Are we still 18? Length 0. Retlen 0 as well. Now we're at position 19 because we read that value, but we actually should be further along because we read a uint 32. Weird. Okay. That gets set to that. Okay. 2 params, 2 results. So that looks good. I guess what would this be? I32. So it should be, yeah, I don't know why it's doing that. It should be 0x7f. Right, if I go like pointer 1, there should be a func type params, and the length is all crazy. Not sure why that is. I wonder if it is this whole deal. Yeah. So that's what's going on. Oh. because we're doing it in the wrong spot. Duh. Whoops, that's stupid. What a dumb issue. I just didn't even notice that. Now we're still crashing, but I think for the right reason now. Yeah, that's very dumb. So... because we want to read the uint first, then get the position, so that way our param position is starting, not where the length is. We were starting where the length was, rather than starting in the right spot. We're still crashing, though. Yeah, we're still seg faulting, which means we're reading bad memory. And actually, I think we can use this skip bytes thing again, now that I'm looking at it. Because now we actually know what we're doing, at least this correct of a thing. So we skip the bytes, param length, and then we skip the bytes of ret len. Ret pause is right after we read the uint. Then we skip ahead, and then we read it. Yeah, why are we seg faulting right there? That's a bit strange. And it's because it's not a stack allocated value, because it's actually... I mean, do we need to do this? I don't think we need to do that. I don't think we need to take the address of the slice. Yeah. Raw params is the buffer from where we started. So, just to make it even more clear what's going on. So the rep pause is right after we read the length, the number of return values. And I don't think it's this. I don't think it's this ULEB 128 thing. Or like how we're decoding the number. So we get the param length, then we read. You know what, let's do a double take on the documentation, because like last time, I was not reading the thing I should have been, and that's what caused the issue. So we have this total types. Now we read, then we resize this buffer, which we don't actually need to do, but, you know, for now it's fine. Then for each total type, or for each type, we read the tag, make sure it's the func type. And I actually like what they did, which was the expected. Actually, it's funny. I said not to do that, so I'm going to stick with my guns for now. And then we read the param length because we have a vector, and a vector is just U32 followed by the element sequence. So we read that U32 for the vector, and then we read all the val types, so we skip over all the val types. And actually, now that I'm thinking about it, we don't want to do the skip bytes because we're basically treating the val types as correct when we do this, when in reality, we want to be able to error handle. We do want to be able to error handle or throw an error, return an error if we read the wrong enum value right here. We do want like some validation. Can I just do this? Neat. We're just going to do that. Yeah, I just thought about that looking at the documentation. So that's not going to fix anything, of course. Oh, and of course we need to... Stupid. We need to do that, which looks so ugly that I'm not going to do that. I'm just going to do this. Okay, so we get the params from the position that we started at to the current position. And, of course, I do not think... Is it just how it's printing it? Now that I'm thinking about it? Yeah, so it's not that. Is it just how we're trying to print it? But, I mean, it should be... We're printing it as any. Yeah, and it's specifically failing when we try to print the parameters. Which is no good. I guess I don't think it's const related. I'm like very certain it's not const related, and we do want that to be const. Right, because it's just a type system thing. That's not actually like a seg faulting related thing. Yeah, so it's the value type. Right, it's just to make sure I'm not doing anything stupid. Func type. We read the number of values. Right, so we read that 0x60. Got that. Then we have the result type of the arguments, which we have vector, which is just the U32 length followed by the encoding. And the encoding is val type, and a val type is just a byte. It's just a single byte. And it's a vec of that. And we read all those. And then we slice the buffer. So what we're reading from that reading position to the current position after we're done reading all the arguments. So if that's 0, or if that's the same position, that's fine. We'll just get a byte slice of nothing. Yeah, and then we make our params. We pointer cast. So that way it turns into the thing we want it to. Then we set the length. So this pointer is the problem. Like the pointer we're getting back is incorrect. For some reason. And actually, you know what we will do for now, just to get the ball rolling, because I don't want to sit here. We're going to do a nice... but I really don't want to do an array list of those. But that's what we're going to do for now. We're just going to do a stood array list of those, because I don't know what's going on with this whole thing, and I would rather move forward than sit here and try to figure it out for like an hour. So we need to do this. We need to make a var. Func type is going to be a type, and it's going to be a func. And all we're going to do, actually, sorry, we even just want it to be a, why did it go all the way down there? What? We actually want it to be a type.func for now. Type.func, and we will do params is this, and returns are that. And now we actually do something with this return value. So func type, we'll call it ft. ft.params.append. We're going to have to try that. This is going to look very ugly. Just ignore it. We don't need that param position anymore. Try ft.returns.append. There we go. And now we're going to append this. Stop func is ft. And we're going to say a nice little to do, this should not allocate. But I am tired and hungry. Alright, so now we actually get what we expected. Because we're fucking allocating memory. Which just means that there is some idea about what I'm writing that was slightly wrong. Where I'm doing the wrong thing. Yeah. And that's somewhere in the code that I'll figure out later. But now we can do this where we go standard.debug.print type boom switch t func. Right, did I call that func? Yes, I did. So func, and we're just going to do ft. And we're going to do ti. So we can do like func of I. And we're going to loop through ft.params.items. Param. Ew, we do tabs. We don't do freaking multiple spaces. What is this doing, man? And we'll do I again, and I think we'll get an error because it's shadowing. And it is. So we need to do something like that. PPI. Yep. Same thing for the returns. So we're going to do like param and return. Just to make sure. I like to do stuff like this just because it's a little fun to see the data in a nice little format when you're working on stuff. A lot of people swear by just doing debugger shenanigans. Oh, we're still getting a seg fault. Why are we getting a seg fault? Type 0. So we say func 0, and then we immediately get a seg fault. That's a bit weird. We shouldn't be seg faulting because we're allocating new memory at this point. Like we're reading the enum value, and we're printing that. Is this union? Is it having trouble with? Yeah, is it having trouble with unions? That doesn't seem right. Or tagged unions? That doesn't seem correct. Is self.types not initialized? I'm pretty sure I initialized it up here in the init function. Yeah, type init. That's a bit strange. I don't know why it's doing this. Because this should have failed if it didn't. Oh wait. Invalidates pointers to okay. Do we actually not want to call resize? Do we just want to do this? Was this the problem the whole time? Was resize the issue? I think resize was the issue. It wasn't even the code. What? Okay, wait a second. Let's go all the way back. All the fucking fucking way back. We're gonna curse because this is weird. Did it invalidate all the pointers so that they're just pointing into nowhere land? Because it had to allocate more? Yeah, that's exactly what happened. Okay, so resize I guess I don't want resize, I guess, in this case. I guess I want, like, ensure total capacity. Yeah, is that what I want instead? Yeah, that's what I want. I wanted to ensure the total capacity. Modify the array so that it can hold the least new capacity items and validates pointers. Yeah, so that's exactly what happened. So because we allocated everything ahead of time, we allocated like 4 functions, and then when we got to the 4th one, it reallocated, thus invalidating everything. And so all of our pointers were just pointing into like nowhere. Pretty sure that's what happened. So on the plus side, we fixed it, and it wasn't the pointer casting I was doing a second ago, which means we actually might not have needed this position thing. But I think we do. I think that was a bug that we have caught. But yeah, let's do a nice little cutesy thing. So let's do a switch T again. Dot func ft. Dot print func, and we're just gonna put the number in there. What would this be? TI type index. So you got to read the documentation, kids. If that's if you're gaining anything from this, you got to read the documentation because it might surprise you. Yeah, it might shock you when you find it, like it just did me. So we're just gonna do. Yep, we're gonna do that exact thing. Thank you. And we'll do a cute little arrow. It already knew. I feel like it's listening to me, actually. Because that's a little weird that it would do that. But I guess it is AI. Oh yeah, we need to also print a nice new line. There we go. So it looks bad because the test runner, but func0 is i32, returns, takes 2 i32s, returns nothing, and then we have func, which takes nothing, returns nothing, and then we have func2, which takes 2 i32s, returns an i32. I don't want that space there. And then we have func3, which takes 1, 2, 3, 4 i32s and returns nothing. So we've successfully parsed one piece of the entire WASM binary. It only took us 3 hours, but there was a lot of learning, whether that was Zig related or WASM related. So I'm not going to be too annoyed. I think the next thing to do would be the next section. So in this case, that would be the imports. I think in reality, I don't want to parse those yet because that's going to involve a lot more stuff. Like if I go back to here and I do my build, it would just be this in the most basic sense, in the most basic case. So I probably shouldn't do that. But yeah, so we just now need to parse a function section, which let's just see what that looks like before we wrap up. Just because I'm a little curious. So I am not in the right spot. Modules, function section. So it's it's just a vector of type IDs, which is convenient. So it is a funcsec is just a section of type IDs, which are just U32s. So I guess the function section decodes into a vector of type indices that represent the type fields of the functions in the funcs component of the module. Yeah, so we have a function section, and all function sections point into the type section, and then we have actual funcs. But that's a little confusing because these have the bodies here. Maybe that's just like a WebAssembly text thing. I think it is, because in reality, these would go into a completely different section, and we can check that in the code. Yeah, the code section. The U3 type. Yeah, okay. So this is where WAT WebAssembly text differentiates from the actual WebAssembly itself, where you make a function and then that will do this whole shebang for you. When in reality we have the code section, and how do we map between the two? I guess it would just be function ID. In this case, we have a function section. So func ID 0 would be this. And its arguments, yeah, okay, so func 0 is this WASM calls CTORS thing. And that maps to type 0. And so when we see the code section, we'll parse func 0, and that will implicitly map to func 0 in the type section, and then func 1 maps implicitly to func 1, func 2 to func 2 or to type 2, and then we parse its body. Okay, so that makes sense. Yeah, I guess when it comes time to do like calls, we'll have to have a way to map between a call to add and how it goes and gets the offset, like its entry point, or like its function pointer. I'll have to figure that out, but that is for another time for me. But yeah, I appreciate you all watching if you are, and yeah, I'll see you in the next one. Hopefully we'll get more work done and not fight with Zig nearly as much. Anyways, see ya.